Hello, my name is Todd Evans and I am a Level 2 Product Support Engineer at Cole Morgan, and this video series is an introduction to the AKD Ethernet IP servo drive. Welcome to video 14 of the AKD Ethernet IP video series. In this video we will discuss homing with absolute encoders. A common question that comes up with the AKD drive is, how do I home or set the reference, or sometimes called origin, for an absolute encoder so I don't have to rehome on power cycle of logic power? This section will cover that topic and also include how it is related to systems with Ethernet IP communications. The AKD-P motion tasking drive has a multitude of built-in home routines that can be found on the home screen and workbench in service position mode. If you look below, you can see that the homing type is shown by the number and the description in the list box. You can see that there are homing routines or homing types such as find a limit input, home input, zero angle, move to the position areas exceeded like a home to hard stop. Later on we're going to focus on 17, which is absolute mode, calculate and save offset. Note on the home screen there is a home start button which executes the home.move command. The home start can be triggered in workbench for testing and commissioning, such as when the Ethernet IP master is not polling at this point and you have control using workbench. Over Ethernet IP, the home start, the home.move can be triggered using the AKD home add-on instruction, which is effectively the same as pressing the start button on the home screen and workbench. It is also possible to perform a sequence of multiple home routines in succession. For example, maybe you want to home to a hard stop and then after that set the origin for the absolute encoder. This is typical in systems where you use absolute encoders and you want to avoid additional wiring such as a home switch. Switching home modes can be done using the AKD set home mode add-on instruction. In the screenshot below, the mode field in the add-on instruction is set to 8, which is find end stop or home to hard stop as an example. You can see in the lower screenshot, which is from workbench, that once that add-on instruction effectively executed and is done, then the home type on the home screen is switched to 8. So therefore you could have two AKD set home mode add-on instructions in your ladder. First you would trigger the first one and set the homing mode to 8, home to hard stop. Then you would execute the AKD home add-on instruction to trigger it. When that's complete, you would trigger the other AKD set home mode add-on instruction and set the homing mode to 17. Then you would re-trigger the AKD home add-on instruction again in order to set the origin or position for the absolute encoder. To reiterate, how do I home an absolute encoder is a commonly asked question. This includes systems with Ethernet IP communication. Homing mode 17 is a homing mode that will calculate the offset, which is the keyword FB1.offset, and it will also store that offset to non-volatile memory on execution. The FB1 extended multi-turn can be set to handle potential rollover on multi-turn absolute feedback types. More on this later. From the workbench help screenshot below, the definition of homing mode 17 is given. In this mode, the drive will first execute an absolute homing and then calculate and store a value for the FB1.offset, so the current position becomes the position specified by the user through the parameter home.p, which you will see is also on the home screen in workbench. The value of FB1.offset is automatically saved in non-volatile memory, so the drive does not have to be rehomed after power cycle when using an absolute feedback device. You'll notice that this is a non-moving type of home routine. This mode can apply to the following feedback devices: single-turn and multi-turn absolute encoders such as BIS, NDAT, Hyperface, and Hyperface DSL, or the Cole Morgan Smart Feedback device, which is used as a single-turn feedback device, or a resolver, which also can be used as a single turn feedback device. This mode does not apply to non-absolute feedback types such as an incremental encoder or a sine encoder. Here's an example of a typical setup for homing mode 17. The home type, you'll notice in the list box, is homing mode 17. Then the only two settings for this particular homing type is the position, and that is the home.p. The position setting on the home screen can be set to 0 or another value that is included in the calculation of the offset used for the top position. For example, if the value is 0, then when homing mode 17 is successfully executed, the feedback position will be set to 0 and the offset is stored in non-volatile memory automatically. If the value is set for 90 degrees, for example, when the homing is run, then the feedback position will be set to 90 degrees and the offset, again, is stored in the non-volatile memory automatically. The other setting is the auto homing. Since the objective is to not have to home on power up every time, the auto homing list box is set to be disabled. Modulo and the use of absolute encoders. In some cases, modulo may be appropriate for your application. This can apply to applications with single-turn or multi-turn absolute encoders. Specifically with direct drive rotary applications and single-turn absolute encoders, it may be desirable to set the modulo so the position is always somewhere between 0 and 360 degrees, for example. Note, the use of modulo is not a requirement to set the FB1.offset, but it may be applicable for some applications, such as a direct drive rotary table, for example. What this means is using homing mode 17 to set the FB1.offset will set the position origin accordingly, but only within one revolution of the motor for a single turn absolute feedback type. Below, you can see from the workbench on the modulo screen that modulo was enabled. You can set a beginning and end point. In this example, the beginning is set to 0 and the ending point is set to 65,536, which you'll recall in our example and setup, we set it up so that in workbench units there's 65,536 counts per one motor revolution. And the direction for absolute motion task has a variation of different settings, such as positive only, negative. That's up to you, but that setting is going to have an effect on if, for example, you've set the origin using homing mode 17 and then you cycle power on your logic power, and then you're going to know where you are on power up. But let's say that as opposed to homing, you just want to send your axis to the 0 position no matter where you are. Then when you command a motion task, or if you're using the AKD move add-on instruction to command an absolute move back to 0, it will take the direction or path based on the direction for absolute motion task if you've got modulo enabled. Let's talk about AKM motors and absolute multi-turn encoders. It is important to understand there is an intrinsic 0 and rollover point for the multi-turn counts in the feedback device. For example, in the AKM selection guide, an AKM5 with either VIS, which is an AB feedback code, or NDAT DB feedback code, has 2048 cycles per revolution. Note 2, which is highlighted below, states there are 4096 turns of absolute positioning. To graphically demonstrate this, there is an intrinsic 0 of the multi-turn feedback device. For the DB and AB encoders, rotating more than plus or minus 2048 turns in either the positive or negative direction will cause the encoder position to roll over, which is generally undesirable. The 4096 turns in the AKM selection guide is based on starting at the minus 2048 turns or negative rollover point and move 4096 turns in the positive direction to the plus 2048 turn rollover point. Conversely, you could move from the plus 2048 turn rollover point and move 4096 turns in the negative direction. But basically, the rollover point is plus or minus 2048 turns in either direction from 0. There's also a parameter in the AKD called FB1.extended multi-turn, which was added in firmware version 1.13.8.0, and later. So if enabled, which is setting the keyword or parameter to 1 and saving it to non-volatile memory, the drive will keep track of the turns beyond the rollover point, and the absolute position will be retained on power cycle. This essentially, when enabled, allows you to not be concerned with the plus or minus 2048 rollover point that we aforementioned. This screen shows the definition from the Workbench help. You can read more about it if you would like. As a summary, here is a note on setting the origin on an absolute feedback encoder using field buses. Ethernet IP, EtherCAT, CANopen, Modbus TCP, and Profinet all have homing methods. How the homing method is triggered depends on the field bus protocol. In some cases, the drive has to be put into a homing mode and then triggered to start the homing. In other cases, it can be done like Modbus TCP, writing to the Modbus register for the home.move parameter, or like in the case of Ethernet IP, using an add-on instruction to start the home. Homing mode 17 is generally a set it and forget it operation where you run it only once. Sometimes when maintenance is done on the machine, such as a belt breaks, a gear head or motor is replaced, etc., or anything that causes the original mechanical alignment and the electrical offset to no longer be accurate, it will be required to recalibrate by executing homing mode 17 again. Often it is desirable to do this without using a PC and Workbench software, hence the ability to run the homing mode 17 from, say, for example, a password protected HMI screen or otherwise is desirable. With Ethernet IP, the add-on instructions that we reviewed gives you this capability. Demonstration number 1, I'm going to show a single turn absolute feedback type and assume that the motor is connected to the load direct drive. From Workbench, you can see that the motor model number is identified here, and it is a CA, or Smart Feedback Generation 3 feedback type, which is single turn absolute. You can also see from the feedback 1 screen that that is the feedback type that I'm using. For this demonstration, I elected to enable the modulo, and I set up a range, since recall that the Ethernet IP drive is set up all for motor only custom and 65,536 counts per 1 motor rev, which is consistent with the Ethernet IP units. So I have my modulo set. It's enabled. My beginning and end point is 0 to 65,536 counts. And then when I want to command a motion task, let's say for example I set up the AKD move block to do an absolute move back to 0 and the drive is homed, then it will go in the negative direction. You can see that there's other choices there. Please see the Workbench help for more details on that parameter. That's the way that I have this set up for this demonstration. Okay, the drive is not enabled. Okay, moving back to the PLC, I'm going to enable the drive. And in this example, I've got 3 rungs. One is a rung that has the AKD home add-on instruction that's used to actually start the home move. And then I have 2 other rungs, one to set the homing mode to homing mode 8, which is home to hard stop, and then I have another one to change the homing mode to 17, which will set the offset and save to non-volatile memory for the absolute feedback device type. So for starters, I'm going to select the home to hard stop. I can go to the home screen and see that that has been selected. I chose the negative direction And I've set up some other settings such as the velocity, the following error that would be considered to be the trigger that you reach the hard stop, and I limited the current down to a low value. And also notice that I've set it up so that when the hard stop is found, then it will zero the feedback position, but then there will be a distance move in the positive direction back half a motor revolution based on the current position unit scaling. Okay, I'm going to start the home to hard stop. Completed. Go back to workbench. You'll notice that the home is found and done, and it moved off the hard stop half a motor revolution. At this point in time, the offset has not been set. Therefore, if you were to cycle logic power at this point in time, you would read the intrinsic feedback value from the feedback device type, and it would not be relative to a home position with your machine. You can prove that by typing fe1.offset, and it's set to 0. Okay, so from the PLC, then, now that we've got it aligned to the machine based on homing to a hard stop, you can change the homing mode to calculate the offset and store to non-volatile memory homing mode 17. If I go back to workbench and look at the home screen, you can see that it's set up for that homing mode. I elected to 0 that position. You could set it to some value, and when you trigger it, it will calculate the offset based on the current position of the feedback device. You could set it to some other value, and then it will set the feedback position to that and calculate the offset based on that number as well. But in my case, I'm going to have it set to 0. So now I'm going to start the home move, which homing mode 17 is a non-moving type of homing routine. And you can see that it did 0 and I'm sitting on the modulo point, a rollover based on the modulo. I can go to the terminal, I can re-query fe1.offset, and you'll see that it did calculate it based on at the time when we ran the homing mode 17. So it should be set up for non-volatile memory, and now we're ready to test it. So before I cycle power, we'll note that where we are. So one thing we could do is jog it a little bit. So I'm going to tell it to jog. I'm going to stop it. And look, and now we're at 305 degrees. Okay. Now I'm going to disconnect. We're at 50,000 counts about, and now I'm going to disconnect. Cycle power to the drive, 24 volt logic power. Okay, the drive has rebooted, so I'm going to reconnect with workbench. You can see I'm still at the same number of degrees within a revolution and the same feedback count. Now, you'll recall that I set up the modulo so that I will go in the negative direction for an absolute motion task. Okay, moving back to the PLC, you will see that I've implemented an AKD move add-on instruction with the intent to command the axis to return to the 0 position. We've cycled power. The drive remembers where it was on power cycle, and instead of homing, I'm going to command it to go back to the 0 position. So you'll notice that the move type is 0 absolute. I have some XL diesel and speed settings, and the go-to position is 0. But first I'm going to re-enable the drive. And now I'm going to command it to go to the 0 position. And it shows process complete. Go back to Workbench. You can see that the position feedback is at the modulo point, which is 0. So this is how you can set the absolute encoder feedback position to somewhere for a single turn absolute feedback type, somewhere between 0 and 360 degrees, and then on power cycle retain where you were in that 0 to 360 degrees, and then command it to go to a 0 position versus having to rehome on 24 volt logic power cycle. In demonstration number 2, I'm going to show the usage of an absolute multi-turn feedback device. From Workbench online with the drive, you can see that the feedback identified as a BSB analog type, and if I go to the motor screen, you can see that the feedback code in the motor model number is AB, which is a BIS multi-turn type. For this demonstration, I've elected to turn off the modulo or disable it. From the terminal, if I check the FB1.offset, it is currently 0. I want to verify that. FB1.extended multi-turn. I'm going to go ahead and turn that on since this is a multi-turn feedback type. I'll save the device so that it saves that setting. Okay, if I look at the current feedback position, it's at some value, and the homing is still set up the same as it was in demonstration number 1. So if I go and I will enable the drive, and then I will make sure that the homing mode is mode 8, home to hard stop. We can go back to the home screen to validate that. And there it is. So I go ahead and start the home to hard stop. Alright. Home is found and done. And it found the hard stop, and then it made a distance move of half a motor revolution off the hard stop. Okay, next, I want this to be now my origin or the 0 position for the absolute feedback type. So I'm going to change it to homing mode 17. Verify, and let's trigger it from the PLC. I'll run the home move again. Okay, so now that position is 0, and just to demonstrate, homing mode 17 set the FB1.offset automatically and stored it to the non-volatile memory. So now I'm going to go ahead and disconnect. I'm going to cycle power on my AKD by the 24 volt logic power. I turn it back on and allow the drive to boot. Now that my drive has rebooted, let me connect. Check. Still at the 0 or origin that we trained it. Okay, moving back to the PLC, I'm going to re-enable the drive. Now we've already proven that if you set the origin and you cycle power, the 24 volt logic power to the drive, and you don't move, then that position will be retained. So now what we're going to do is we're going to simulate, say for example, an actuator to extend out to some position, and then let's say that you power down the 24 volt logic power and then you reboot. Then instead of having to rehome, you just simply command the axis to go to the 0 position. So in order to do that, what I'm going to do is I'm going to just simply jog it out so that the feedback position is some non-zero value. I'll stop it. Back to workbench. So this is my current position feedback. So we'll remember that number. And so now I'm going to disconnect, and I'm going to cycle 24 volt logic power. Now my drive is rebooted. I'm going to reconnect. I'm going to re-enable the drive. If you look at the current feedback position, we've still retained the previous value before power cycle. So now we're already home, we know where we are, but let's say that the process requires that we start at the machine mechanical 0. So all we have to do now is to command an absolute move back to 0. So jumping back to the PLC, I've added an AKD move add-on instruction, the move type 0, which is absolute. I've set XL, decel, and speed values, and the target position is 0. So now I will trigger that. Process complete. And if I go back to workbench, I'm back at the 0 position.